Hey guys, and welcome back to a new video of this KMP playlist in which you will learn how you can write test cases for your Kotlin and Compose multi-platform project. So specifically, I will lead you through the different testing scenarios that you might face when working on a Kotlin multi-platform project. On the one hand, that means that you will learn how you can write unit tests for your common code, so for the shared code section. You will learn how you can write unit tests for platform-specific code. You will learn how you can write UI tests for the shared Compose multi-platform code. And lastly, you will learn how you can write instrumented Android unit tests, or just instrumented tests in general. So those are tests that involve dependencies from the Android SDK that have to run on an Android device, which is a type of test that is included by default in pure Android projects, but in Compose and Kotlin multi-platform, it works a bit differently. And I will say right away that this won't be a video where I go over testing theory in general, what testing is about, good strategies for testing, how you write good test cases, and everything that belongs to this big topic. If you want to learn about that, and if you want to learn proven strategies, how you can really reduce the bugs of your apps to an absolute minimum and highly increase your confidence over your code base, because you can always just verify that your code still works as expected with a single click. And then I will host a free live workshop on Sunday this week at 3 p.m. UTC time. Registration is completely free. You can just join. You can save your spot by clicking the link down below. It's interactive, so it's live. That means we can interact with each other. You will be able to ask me questions at the end about testing, be it on Android, be it on KMP. And this workshop, I will really just lead you through my proven testing strategies, what is really important to consider when applying test cases. So even if you've never applied testing before, this is the workshop for you to attend. So this won't be the topic of this video. What will be the topic is if you know how testing works and you know what it is generally used for, but just not in the context of a Kotlin multi-platform project with a different source set we have here, with the different types of tests. As I said, if you want to learn how you test Compose multi-platform code, if you want to learn how you test shared Kotlin code, platform-specific code, that is what this video will be for. So as usual in this playlist, if you want to follow along, you need to go to kmp.jetbrains.com, create your project for Compose multi-platform, tick Android iOS desktop, download it, open an Android Studio, and then you can just follow along from there. I've already done that. Let's open this. Make sure to be in the project view here and open our Compose app module, source, and I want to start with writing tests or unit tests for our common code. And that's really a superpower of Kotlin multi-platform in the end, or of cross-platform development in general, because code, or a lot of your code, is shared between all different platforms. But since you have that code only at one place, that means you also only need to write one test case which covers testing logic for all different platforms you're targeting. And just for this common main code, I added a little sample function. You can, but don't have to use exactly that one. If you want to also copy paste this, I'll include a GitHub link down below. It's in the end just a function that retrieves a full name's initials. So it worked like this. For Philip Lagner, it would be PL. If we just pass Philip as the full name, it would be the first two letters. And if we pass more than two names, then it will still be the first and the last name's initials. So that's a perfect function to write unit tests for. And normally we would just go ahead, say Alt-Enter here on this function name or class, whatever you want to test, create test, and then it will tell you there are no test routes found. Because normally the way testing works is we have our production code source set. So a source set, little recap, is just what we have here, like common main, Android main, desktop main. So just a folder that contains files and Kotlin classes for a specific purpose. And then different such source sets can but don't have to rely on each other. So for example, Android main relies on common main, since we can access everything from common main in Android main, but not the other way around. And the same way, if we want to write test cases, then there must be some sort of test source set. So with the code that is only needed for test cases. And that code should of course not pollute our production APK that we generate for Android, our production app in general, because it's only meant to be used for test cases. And that's what we use a test source set for. And we can create this here by going to stores, creating a new folder. And here there are a bunch of source sets that Gradle suggests us to create by default. For unit tests, we want to type common test, and you can see that is the directory we want to create here, common test/Kotlin, which will create this new source set. And inside the source set, we will now put in all our tests that involve our common code, or that test logic from our common code. And since our getInitials KT here, our function that we opened, is contained in our shared code, the right place for the test for that is also in this common test. So let's try this again. Alt-Enter, create test. This time we don't get the pop-up that this test route is missing. You can see the default testing library here is JUnit 5, which is the Java testing framework. That's the default for Android apps at least, which is why Android Studio also suggests that here. or JUnit 4 is the default right now, but both JUnit 4 and 5 we could use for Android apps. However, you can already guess that this won't work for Kotlin multiplatform because JUnit, as the name says, is based on Java. However, JetBrains ships its own kind of testing framework, which is purely based on Kotlin, luckily. We can select that here, but that's not an issue. We can just hit OK, and then Android Studio will place this new test, this getInitialsKT test, here in our command test Kotlin source set, getInitialsKT test, and you will notice that the import is not recognized because we don't have access to JUnit here, so we can safely remove this since we will use the Kotlin testing framework. The Kotlin testing framework is very similar to JUnit 4 in regards to the annotations, so we could annotate this with a test here, but you will notice there is no test annotation here, which is actually called exactly the same in the Kotlin test framework. The reason for that is that we haven't yet added that dependency, that Kotlin test framework, to our project, that we really want to use this for this certain source set here. We can change this by going to build.gradle, scrolling down where we have all of our different source sets and where we define which dependency should be included for which source set, and we just add another one, which is in this case common test. So we want to say the common test source set also has its own set of dependencies, which we only want to use for that common test source set. And here we can say implementation libs.kotlin.test. That is the Kotlin testing framework, which is already contained by default here in KMP projects. We can also add a little extension of that to get some more annotations and utility, which we can add with Kotlin and then annotations.common. However, that will not be enough here just to add this Kotlin testing framework, because I also want to show you my preferred approach of writing test cases for the libraries that I like to use. And for that, let's open our version catalog in Gradle. libs.versions. I want to copy paste 4 of my dependencies. Again, copy paste these from my GitHub repo down below. That's on the one hand assert_k, that is an assertion library for Kotlin, purely written in Kotlin, which works very similar to the assertion library Truth from Google, which is based on Java, and assert_k is the Kotlin equivalent kind of, and just makes our assertions a lot more readable. We also want to add these Compose UI testing Android-specific dependencies here, since we need these for the Android side. And the core KTX dependency is just something I want to show you for the instrumented Android tests later on. We can then also paste the 3 versions up here for assert_k, core KTX, and compose test, and then we can sync this and add these to our Gradle file. There we go, sync was successful. We can duplicate this here and make sure to add the assert_k dependency as well. And we want to add the compose UI test dependency as well. Without manifest, it's actually not like this, just libs. What is it called? Compose. Yes, compose. This comes from the Compose JetBrains plugin, so we can directly refer to compose and then refer to UI test. So that already ships with all the related compose specific dependencies. This Compose UI test framework for Composable multiplatform is still experimental, still not fully stable, but we can make that work. So we can opt into this experimental compose library annotation and just add this here to the statement. But again, we will first of all deal with unit testing. Let's sync this and then go back to our getInitialsKT test. And now we should hopefully be able to also import this test here, which seems to look like that. Yes, Alt-Enter, import that. And now we can just write a very simple test case that really works just like with JUnit at this point. Test getInitials or so. Let's keep it simple. We have some sort of full name, which is, I don't know, Philip Blackner. And then we run our assertion with assert_k. That always starts with assert that, which keeps it very readable. I want to assert that getInitials with our full name dot is equal to PL. That is what we want to test here. And of course, in a real app, I would test all different kinds of scenarios, including edge cases and so on. But we really just want to learn how testing works in this common test source set. If we now click on this play symbol, run this, we need to select which device we want to run it on, because generally there is no common device kind of. We can target different platforms, but if we want to build and run code from the common main source set, then we still have to pick a platform we want to make that run on. Either way, that shouldn't change anything because it's the same code that is run and tested here. So we could pick desktop, for example, and then it will initialize these tests and hopefully tell us that it passed. Yes, you can see the test passed. We get a check mark, very cool, and also the information that this was run on a desktop device. One thing to note here about the testing framework maybe is, as I said, right now we use the JetBrains Kotlin testing framework, which is very basic. So if you've been working with testing already on Android, then this is a lot like JUnit 4. But if you're into testing, then you will know that we can also already use JUnit 5 for Android testing. And JUnit 5 just brings a lot more cool features, for example, like parameterized tests, which let us test a single function with various different inputs where we just define, hey, for this specific input, this is the output we expect. We define that as a big list, and then we just need to define the test case once, which goes through all these different inputs and expected outputs to verify that these actually match. This is not possible here for Kotlin Multiplatform. If you want that, then there is still a way to do so. You can use the also popular code test testing framework, which works for Kotlin Multiplatform. I've tried it and it's still a little bit hacky for KMP, not in general, but for KMP. So it's a quite different paradigm to testing. The test cases will look quite differently. But it brings a lot of different utility that allows you to write much less code for your test cases. So the framework itself is great, but for KMP, it's still, as I said, a little bit hacky. So this means you won't yet get an IDE plugin, which it actually has, but that won't work for your common code. And instead, you will have to run your tests with a Gradle task. You don't get the nice outputs like here with the test results, at least for the common test yet. But I'm pretty sure that this will follow in future. So for now, I will probably stick to the officially supported JetBrains Kotlin testing framework. And then once other frameworks really become superior, I would switch to these. All right, common unit tests, check. Let's next focus on unit tests, but for a platform-specific source set. So what if we actually have code, let's say here in desktop main. So we have some sort of class here. Let's just keep it super simple again, get string length or so, I don't know, make that a function. And here we have a function that get string length. We pass in some sort of string and it will simply return the length of the string, just to have some kind of demo here like this. And we now want to test this function here and verify that this works. And we assume that this is a function that is only available on desktop devices. That's why we put it here in desktop main. We can access that in common main, Android main, or iOS main, but only for desktops. And that really works no different than what we already did for the common test. So we again go to our source, create a new directory, and this time we want to write desktop test. So we want to write or create a test source set just for desktop devices. Create that, and that is now our directory where we put our desktop tests. And that actually has a difference compared to common test, because if we are on desktop, and that is a JVM environment, that means we can also use frameworks like JUnit 5 for testing. So here we are not bound to the requirement of only having Kotlin-specific libraries and dependencies. But I would say adding such framework just for a specific source set, like in Android main, we could also make that work, but also in desktop main, would only really pay off if you have a lot of platform-specific code, of course. I probably wouldn't add that for a single test case or so. So in the end, your goal is to put as much code as possible in your common main source set. But to just also lead you through a little demo here, we can Alt-Enter on this function name, create the test, click OK, and now we will be able to find this here in our desktop test source set. Can remove the JUnit import again, since if you want to use that, you would need to configure it in Gradle. But here, we can just add a test. You can see here we have the normal JUnit import, so JUnit 4, or the Kotlin testing framework. Let's stick to that and say test get string length. There we go. And we assert that, I don't know, let's say ABC, actually get string length with ABC is equal to 3. That is what we expect. If we run this, then that probably won't be a surprise to you that this test case passes. But that is in the end how we write unit tests for platform-specific code. If you would now want to write a unit test for the iOS-specific code, you would again go ahead, create your iOS test source set /Kotlin, you would put your tests in there, and so on. All right, what is next? Now that we learned how to write unit tests for shared code, for platform-specific code, let's learn about how we test our UI. And our UI in a Composable multi-platform project is, of course, in our shared code. So here, in the Kotlin common main source set, we have our entry point for Composable multi-platform, and let's just create a very quick counter composable or so, where we just display a text together with a button. When we click the button, we increment the counter, and for that, we write a simple test case. Make that a file, call that counter, and we really just have a column here we have some sort of count state. We say by remember, oops, not that one. By remember, add a mutable in state of 0 initially, Alt-Enter to import that, and then we have a text that displays this counter to string, and we have a button that increments this when we click on it. So here, on click, we say count ++, and the text can say, okay, increment. There we go. So very simple UI. We don't care about any sizing here. We just care about that these two composables are on our screen, that somehow display our count, and we increment it when we click on the button. And that behavior we now want to test with a UI test, that we really simulate the clicks, that we really simulate reading that count value and checking if it was properly incremented. And the way this works is, as I've already shared, for a Gradle, you would need to add this compose UI test dependency to your common test. And then we can also put this UI test here under our common test source set. So let's create a new class here called counter KT test. And in here, we will also have a test case, function test counting up or so. I don't know, let's choose very basic names. And this now has to use the run compose UI test function. So normally when we run compose UI tests on Android, then we need to create a so-called rule, which is very dependent on JUnit. We don't have that here. So JetBrains offers this run compose UI test function. You need to hit Alt-Enter here to also opt into this experimental API as usual. Then the error will go away. And with this compose UI test scope here, what we can do is we can try to find certain composables on our screen, usually based on content description, based on the specific text they display, based on certain test tags that we assign to them manually. And then we can perform actions on these. So just like in a normal test case, the difference that our UI is really involved here. So first of all, we want to say, okay, we set the content to something, to a composable we actually want to test here, which is our counter. And based on that, we can now execute these actions and run assertions. And this works with, actually not Composable, but on node with text. So we want to find a node, a certain composable on our screen, by the text that it currently displays. Let's say we first of all want to make sure that the text initially displays 0. So we just try to find the node with the text 0, and we assert that it exists. And at the same time, we want to assert that the node with the text 1 does not exist. So just to make sure that we really have a solid assertion here and the state of our composable is properly changed when we tap the button. That is what comes next. So next up, on the node with the text increment, which is our button, we want to perform a click. So we click that, and after the click, what happens is we expect that there is now a node with the text 1, and there is no node anymore with the text 0. So again, copy paste this and just swap this out with 1 and 0. So for the 1, we assert that this exists, and for the 0, we assert that this does not exist. That's our UI test. Let's run this. And again, we need to pick a device to run this on. In my experience, desktop is typically the pick you want to make here. If that doesn't work, iOS also works. For Android, I wasn't able to make this run yet. I always got some kind of null pointer fingerprint exception or so. And after a little bit of research, it seems like it's just because this framework is not so stable yet. I might be wrong. There might be a workaround. That might very well be. I didn't want to spend hours to fix this, which will probably become much more stable soon anyways. But again, we test shared code. The code we test is independent of the platform here, unless you, of course, have certain screen size differences here or so. But other than that, the composable will look the same on desktop than it will on iOS, for example, usually, if you don't have that individual difference in UI. So let's run this on desktop. This will, of course, yes, build a little bit longer. No, it actually doesn't build a little bit longer. So it immediately finishes, you can see, and we get the check mark. And you will also notice that if we go back to counter and we would say we would decrease the count here, then our test case should hopefully catch that. Let's rerun this. And yeah, now our test case breaks, because it expects a node but could not find a node that satisfies our constraint that it has a text that contains 1, because there was only a -1. All right, that's how you test compose multi-platform code. Lastly, let me actually show you first that this did not work on Android. Counter KT test, let's go here. We run this, actually modify the run configuration, run this on Android, click OK, run this again. Hello? Yes, that is always the issue I get. Unresolved reference run compose UI test, probably because Android expects its own kind of JUnit compose rule or so. I don't know, just an assumption, but I would just run the UI test either on desktop or on iPhone, because on desktop, as you just saw, that'll work just fine. Okay, last thing I wanted to show you as promised is how you can write instrumented tests just for Android. So instrumented tests on Android are those tests that access dependencies from the Android SDK. And in Kotlin, if you have code that is only relevant for your Android source set, then it's very, very likely that you will also need to write an instrumented test case for that. Because if the code would not be dependent on the Android platform, you wouldn't put it in Android main in the first place. And in order to make this work, we again, surprise, surprise, create a new source set. And this time it's called Android Instrumented Test Source Set. That's a bit different than on Android. There it's just called Android Test. Here it's called Android Instrumented Test. Create the Kotlin folder. And in there, we can create a little test case. And I quickly want to confirm that I added the JUnit dependencies to Android. No, I did not yet. So there are just certain things we need to set up here for this Android target block in our build.gradle file in order to make this run. And we do this with instrumented test variant, this block here. Again, Alt Enter to add this opt-in annotation. And in here, we can now configure how we want our instrument tests to work like. First of all, we want to set this source set tree to, what is it? Kotlin source set tree.test. Just say, hey, we have a test source set here. And then we want to add a dependencies block, which will now be the dependencies block for our Android instrumented test source set. So all dependencies we add in here will be used there as well. That's on the one hand. In our case here, simple case, of course, you can add more libs.core KTX, which allows us to access things like a context in instrumented tests. It is an implementation libs compose UI test manifest, no, actually JUnit 4. So JUnit 4.android and UI test manifest, which needs to be a debug implementation. Those are just Android reasons why this needs to be a debug implementation, since that only needs to be in the debug APK, but not yet in the test source set. And this is just in order to be able to run UI tests for compose code that is specific to the Android platform. So if you have Android compose code in your Android main source set and you want to test that, you will need this dependency. So that's also a bit different compared to how testing worked on Android, where if we wanted to add a dependency just to the Android instrumented test source set, we had to add this with Android test implementation. Here it's different. Here we just add this to the Android target and the instrumented test variant, where all dependencies we place here with a normal notation will be added to the instrumented test variant. One last thing we need to add is down here where the normal Android APK is configured. Under default config, we want to add a test instrumentation runner. So on Android, we want to use the normal JUnit test runner. You can see it's suggested here, Android x.test.runner, Android JUnit runner. So we just need to configure that here in Gradle, so the instrumented testers know what specific test runner to run on. You will need to change this if you use things like Hilt or dependency injection frameworks in general that require a custom test runner, but that's not the topic of this video. That's covered in my testing course. So let's sync this and then get back to our Android instrumented test source set, where we just have, let's call it a sample test or so, just to see that we can really access Android specific dependencies here, like the context. So we can say we have a test. You'll notice, okay, here we want to use the JUnit one since we are on Android. Test context or test package name, let's call it like that. That's what I want to do. Package name. We can get the context here with application provider. That's only available for instrumented Android tests. We add the context reference, and then we can run an assertion on that where we say, okay, we assert that the package name is actually what we expect it to be, like in my case, compl coding KMP _ test. If we execute this, we should hopefully see a passing test. I am seeing on my different monitor that my emulator is booting up, which is good because that is what is required for an instrumented test. It will build a little bit since for instrumented tests, actually APK has to be built in order to run this on an Android device, of course. So Gradle will do its job and then hopefully run and pass our test. And there we go. The test failed, but it ran. Assertion fail error. but it was actually, okay, I misspelled the package name. It's actually KMP testing, what my package name was, not KMP test. Relaunching this, and it should hopefully give us a succeeding test. Yep, there we go. That is our very first Android instrumented test for a KMP project. So again, if this was interesting to you and you want to learn really proven testing strategies straight from the industry, then just register for Sunday's workshop. Again, completely free. You can just register and save a spot right now. Better to do it now than later, because my webinar paid plan actually has a limit on participants. And then we can have a cool session on Sunday where I'll also answer your questions about testing. Thanks for watching this video, and I will see you back in the next video of this KMP playlist. Have an amazing rest of your week. Bye bye.